All right, we've talked about writing equations and solving equations and what variables and all those things are, how they're used. And now we're going to head into inequalities. An inequality is a number sentence that uses less than, or equal to, greater than or equal to, or not equal to. Um, so you can see what these symbols mean and what they are, just their definition right next to them there on the screen. The prefix in means not, so an inequality means not equal. So if it's in, it means not. Inequality means not equal. The two sides are not equal like they were in an equation, so they are different that way. However, on the next slide, you'll see that even though they're different things, they actually get solved in the same way. Solving inequalities, I just copied this slide from a previous lesson. Get the variable all by itself. Adding is the opposite of subtracting, and multiplying is the opposite of dividing. So even though these are um, different than equations in that the two sides are not equal, the way that you solve them is real similar. And we'll see that as we continue to solve some here. Okay. All right, so give all of the solutions from 0 to 10 that will make this inequality true. So as you look at this inequality down here, we have x plus 5, and this side is less than this side. They are not equal completely. This little bottom thing says that they could be equal. So we will have one solution here that will make them equal, but all the rest of them will make this side smaller or this side less than this side. All right, so x is not by itself right now, so we're going to do what we can to make it all by itself. Just like I showed you in the previous lesson, you have some different strategies you can use here. I'll use one strategy I used earlier, or right at the end of the last lesson. Since I have this plus 5, if I'd like to get the x all by itself, I'm going to subtract 5 from both sides. So I'm just going to put minus 5 on this side and minus 5 on this side. If I do it to one side, I have to do it to the other. So the whole reason I chose 5 here is because then x would be all by itself. 5 minus 5 is 0. And now I have x plus 0, which basically means it's all by itself. I have nothing added to it. Less than or equal to 6 minus 5, which is 1. So x, whatever x is, this unknown, this variable that we have, is less than or equal to 1. So I go back up to my number line here now and take a look at all these numbers on this number line that are less than 1 or equal to 1. 0 is less than 1. And 1 is equal to 1. 2 is greater than 1. 3 is greater. All these are greater than. But these two right here, this is less than 1, and 1 is equal to 1. These are my solutions that will make this inequality true. Give all the solutions from 0 to 10 that will make this inequality true. G, whatever that is, minus 4 is greater than or equal to 2. So you can see that G is not by itself right now, and I'm going to um, make it that way. I'll use a different strategy this time, the one I was using with the curved arrows. If I go in this direction and I subtract, then I should be able to start in this direction and do the opposite. So if I subtract it in this direction, I'll add in this direction. 2 plus 4 is 6. And that would mean that G is equal to 6. Oops. Almost kept it equation there. Put in my greater than or equal to. That means g has to be greater than or equal to 6. Okay, so 6 is equal to 6, so that would be one of my solutions. 7 is greater than 6, so that would be a solution. 8 is greater than, 9 is greater than, and 10 is greater than. As you get further in, they'll actually include this 6, and then this will be something you'll do further on in math, and you'll just make a curved arrow or a darkened arrow shaded over this entire thing, and you'll include this. But for now, in fifth grade, the level we're at, just putting a dot on each one is totally okay. So we have 6 minus 4 is equal to 2. 7 minus 4, that's 3, which is greater than 2, and so on. We didn't have 3, for instance. 3 minus 4 would be a negative number, which would be less than 2. 4 minus 4 is 0, which would be less than 2. So these are our solutions right here for this inequality. All right, we'll try this one. This one does not have that little line underneath there. And so this is not, we won't have one that is equal to. Only greater than, and that's it. All right. P plus 5 is greater than 12. I'll use that first strategy I used earlier. I'll subtract 5 from both sides to get P. I'm not going to subtract 3 because I'll have P plus 2 then. It'll still have something attached to it. The whole point is we're trying to get that P all by itself. And so the number we choose is real specific so that we can get it all by itself. I'm going to subtract 5, which would make 0. So that would have P plus 0. So adding nothing to P greater than. Can't just do this minus 5 to one side and not the other. I have to do it to both sides. So P plus 0 is greater than 7. So P is greater than 7. Okay, so we're going to go up here now to the number line. If I was to choose 7, that would be 7 plus 5 is 12. And that is not greater than 12. It's equal to 12. So 7 would not actually be one of our answers this time. 8 would be. 8 plus 5 is 13, and that's greater than 12. 9 plus 5 is 14, and that's greater than 12. And 10 plus 5 is 15, that's greater than 12. Just for the future, there would actually be a dot on, an open dot, a circle, on the number 7, and then all of these would be shaded in for a number line. This would be something you'll do as you get further on into math. An open circle means you're not including 7 in all of these. On the previous one I showed you, that one was actually equal to, and we filled that dot in and then went up above. Okay, so here are inequalities and the way that you solve them. Hopefully now you see that that's pretty similar to the way you solve your equations, but it's important to keep them separated and know that an inequality uses less than or less than or equal to, greater than or equal to, or not equal to.